You have your notes out. We're adding to our notes. Next example. X minus 4 over 9x minus 18 minus, Ms. Rice, are we ever going to do plus? I have no doubt that you can add these. I am doubting whether or not you can subtract correctly. So we're just going to keep doing subtraction. We're going to roll with subtraction. 6x over 3x. Why is it so bright right there? There's just like one bright spot on the screen. All right, I'm going to zoom in. Okay. So what do we do first for a day like today where we have two denominators that are not the same? We got to get a common denominator. We're going to do it by kind of like breaking down the denominators, and that's by kind of like factoring them, right? So when we factor the denominator for the left side, what type of factoring is that? Yeah, GCF, greatest common factor. What's the greatest common factor between 9x and 18? Did you just flip her off with your ring fingers? They were your middle fingers. They were your pointer fingers. Oh, you're denying that you did it when I clearly saw you. Oh, okay, okay. All right, so the greatest common factor is what? 9. And then what's left over? Okay. And then over here, all we have is like a 3 times an x. That's like all we have. Okay, so I'm just gonna, just so I don't get confused, I'm just gonna kind of like lightly scratch these out because I've kind of like dealt with them. Okay, so if I'm trying to figure out what's common between them, I could think of the 9 as like a 3 times 3. Does that make sense? To kind of relate the two a little bit better. All right, so our common denominator needs to have what? It definitely needs to have a 3 because each of them has at least one 3. In fact, how many 3's does our common denominator need to have? It needs to have 2. So between the two denominators, we need to have at least 2 3's. So 2 3's. What else does our common denominator need to have? An x. And then what else does it need to have? It needs to have an x minus 2. Okay, so we're going to make a conclusion that our common denominator is 9x times x minus 2. Are we comfortable with that conclusion? Can we kind of see how we arrived at it? Okay. All right. So this one already has a 3 and a 3 and an x minus 2. So what does it need? It needs another x. Okay, so I'm going to do this in another color. You guys said green, but I couldn't find my green, so I'm just going to use blue. I like the blue because it is so blue. So easy to see. All right, this one has a 3 and an x. So if I cover that up, a 3 and an x, what does it need? An x minus 2, and it needs another 3. So I'm going to give it another 3, and I'm going to give it an x minus 2. Okay. Okay. All right, so I'm going to take the original problem. I'm going to write the original. I've got x minus 2, or x minus 4. Huh? I'm going to show you, that's what I'm going to do right now. So I'm taking the top, the original top, and I'm going to write the bottom now. I've got 9x over x minus 2, and I have to take the top and I have to multiply it. Actually, hold on, I'm not going to write this. I'm going to write it, I'm not going to do this in a confusing way. I had that 3 times 3. I am multiplying this times x on the top and x on the bottom. So that's how I'm adding in the x that I need on the bottom, is I'm multiplying the same thing on the top and the bottom. Does that make sense? Same thing. That's how I'm doing it. So as long as I do the same thing on the top and the bottom, it's like I'm multiplying the whole thing by 1. So I'm changing what it looks like, but I'm not changing what the value is. I'm not changing what is represented there because I'm multiplying it by 1. Top and bottom, yeah. We're going to do it to the second expression as well. So the next one, we had 6x over 3x. On this one, we're going to multiply it by 3, but we're also going to multiply it by x minus 2. Okay, so I'm going to go ahead and clean this problem up. So I've got x squared minus 4x. I am not going to distribute things on the bottom because I know the bottom is not going to change at all. On the top, I do have to distribute things because I have to be able to combine all my like terms together. And then once I combine all my like terms together, then I'm going to factor the top. But I have to be able to combine my like terms first. So on the top, I had x squared minus 4x. On the bottom, I can just say 3 times 3 times x is 9x, and x minus 2. On the bottom, 3 times 3 times x is 9x, x minus 2. And then right here, what is 3 times 6 times x? Okay, so I have 18x, 18x times x, 18x times negative 2. What is 18x times x? Okay, so we had a negative 18, actually, hold on. I'll just write it down here. We had 18x squared, and then 18x times negative 2. What's 18x times negative 2? All right, so what should we do now with that minus? Now we can go ahead and distribute it. And I think in the video was only getting common denominators, right? So in the video you stopped. Is that right? Okay. So here we'll just go ahead and keep going and we'll see what the problems are going to do. Because what I had to do is last year when I taught this 2-year-long Math 3, we had twice as much time as I have to teach it to you guys, right? Because it was a year-long class instead of a semester-long class. So we did these lessons in like 5 days instead of like the 2 days that I have for you guys. All right, so let's go ahead and distribute that negative. What do we have next? Okay, and then what should I have on the top? Perfect, okay. Now what should I do? Combine like terms. So if I combine my x squareds, what do I have? Okay, and if I combine my x's, what do I have? It's 32x. Okay. And then what type of factoring do I do for the top? GCF. And what's the GCF on the top? We take out the negative, and then what do we take out with the negative? An x. Okay, so we're going to take out a negative, and we're going to take out an x. So I'm going to do -1 and an x. Okay, and then does anything cancel? The x's do. The GCFs in the front, the x's of the GCFs in the front do. The coefficients don't. The -1 has to stay, the 9 has to stay. But the x's, since they were being multiplied by those coefficients, -1 times x, 9 times x, and then this is division, multiplication and division do cancel. So those x's do cancel. Okay, comfortable? Okay. Now, I think we could probably benefit from doing more examples, but maybe another example should be done on the worksheet itself so we're doing some of our homework. Does that sound good? Okay. Let's do that. Can't wait for you guys to the math jump and figure out the functions. It's so good. Oops, sorry.
Are you
All right. So we're going to look at number 6. Looking at number 6. All right. Yep, number 6. Okay. So if we look at these denominators, we're going to start factoring them. So I'm going to say that if we were to factor the left one, I would just call that 2 times 3. If you factor the right one, what would you guys do? Take out the 5, okay. All right, so what does our common denominator need? Yeah. So if we multiply the 2, the 3, and the 5, 30, okay. So the 2, the 3, and the 5 times the n plus 1 is going to help us get our common denominator. The 30 times n plus 1 is what we're going to be seeing in the problem. Okay. So the left fraction has the 2 times 3. If it's got the 2 times 3, what does it need? So I'm going to go ahead and look at my common denominator. It has the 2 times 3, so I'm going to cover those up. What does it need? It needs the 5, it needs the n plus 1, and it needs those on the top and the bottom. Okay. So there's my left fraction. The right fraction yeah. Yeah.
Times 3 and 5. What's the 5? Is 5 multiplying times 3? Oh.
Okay, so this one has the 5 and the n plus 1. So what is it missing? The 2 and the 3. Okay. All right. Brains are okay? Okay. So we already said that the bottom, if we did 2 times 3 times 5, that's 30. 2 times 3 times 5 is 30. Okay. What is 4 times 5 times, or 4 times n times 5? Okay, so if we have 20n, and we take that 20n and we distribute it to an n plus 1, what do we get? Okay. All right, over here, we have a 2 times 3, which is 6. So we have 6 times 6n, which we said was 36n. And then 6 times 6 is 36. So make sure when you're doing these, just don't rush. Okay, as long as you're taking your steps and going slow enough. All right, so we're going to make sure to distribute our negative because we're not killing any. Is it the baby foxes? Is that the distributing the negative one? I think that's baby foxes. All right, so on the bottom we have 30 times n plus 1. On the top we have 20n squared plus 20n. And then what do we have? Okay, and then we're going to go ahead and combine like terms. So when we combine like terms, what's the middle term? Okay. No. See how the top is a trinomial? Yeah. So on the top, do you see a GCF that we could take out before we try to do probably a slide divide? 4. So you can't do a slide divide before taking out a GCF. You have to take out a GCF before you do slide divide or you'll get it wrong. So we'll have to take out the GCF first and then do a slide divide. Is that what you were asking? Okay. So we're going to take out the 4 first. So 5 times negative 9 is negative 45. So we're looking for two numbers that multiply to negative 45, but add to negative 4, negative 9 and 5. Okay. So we have n minus 9, n plus 5. So what I'm doing right now is I'm just factoring the top. N minus 9, n minus 5, or n plus 5. So am I done factoring the top? Divide by 5. So the number that we slid is the number we divide by. Okay. So what's the first set of parentheses? What's the second set of parentheses? Okay. So on the top, what should I have? Wait, before I even write the parentheses, what should I have on top? 4. Okay. Wait, is the 4 negative? It was a pencil shaving. It was a pencil shaving. I'm so sorry. Okay, so we have a 4. We have a 5n minus 9. We have an n plus 1. Oh, you can't even see what I'm writing. Okay, so there's the top. We have a 4. We have a 5n minus 9. We have an n plus 1. Then we have a 30 and an n plus 1. If you wrote it as 30 n plus 30, then you wouldn't be able to reduce the 4 and the 30, which we're going to have to do. Okay. All right, we are finally at the place where we are able to see what can reduce. So what are the things that you can reduce? The n plus 1s reduce. What else reduces? The 4 and the 30. You can divide a what out of both of them? A 2. So the 4 becomes a 2. The 30 becomes 15. So on the top we have a 2. We have a 5n minus 9. On the bottom we have a 15. By golly, we've got it. All right, what answer does that correspond to? What letter is that? It's an E. What's that? Oh, that's a different E. That's an E. So for number 6, I put an E. Probably. I ran out of letters, okay? Yes! The punchline is fun, but it's not the purpose of the whole worksheet, sir. Okay. Let's do one more. I want you guys to look at the entire worksheet, and I want you to find one that feels intimidating. So look at the entire worksheet. Your opinions don't count. I just did one for you.
Can we do all of them?
No, we cannot do all of them. So find one that feels intimidating. Find one that feels intimidating. Does 4 feel intimidating?
No, it doesn't.
You just add it 5. Do 9.
9.
Sure, I think, yeah.
Is 9 the vote? 7?
9 is probably 8, 3, 9, 7.
7.
All right, we're gonna vote. We're gonna vote by table. I know that table's vote is 8. What is your table? 7 or 9? What do you guys think? Sam, Alex, Emma? You don't care? 7? Lucas, Jack, Wade? You don't care? 4? Daisy, what's your vote? 7? Okay, I think we're doing 7. All right. If you look at 7, if you look at 7, how do you deconstruct the left denominator? So that one's 2 times n. What's the left one? What do we look at when we look at the left denominator? How do we factor the left denominator? How do we factor the left denominator? 10 out and what else? And an n. So it's a GCF of 10n, and then what's left over? N plus 1, okay. And then the 10 of 10n, the 10 is really a 2 times 5 times n in front of the n plus 1. So we have a 2 times 5 times n, which is what makes up the 10n. 2 times 5 times n plus 1. And a 2 times n for the right fraction. So the overall common denominator, if we compare the two, what does the overall common denominator need? So a 2 times an n for sure, they both have that. And then also a 5. And then also an n plus 1. And the 2 times 5 times n is what when we clean it up? 10n. Okay. Okay. So if we look at the left fraction, can you guys see how it already has the pieces? Okay. So the left fraction is done. It doesn't need anything. We can, so you can write it in that, but think about it, we like it to be in the factored form because when we're done, we like to cancel things. So I like to leave it factored because I'm going to have it factored eventually anyway. So I'm going to leave my first fraction as 4 over 10n times n plus 1. Plus, look, you guys, our first addition problem. That's so fun. All right, the second fraction is 2 over 2n. So I'm going to cover up the 2n. In my common denominator over here, cover up the 2n. What does it need? It needs a 5, and it needs an n plus 1. Okay. So for the left fraction, we have the 4 over the 10n times n plus 1. For the right fraction, we have the something over 10n times n plus 1. On the top, we have 2 times 5, which is 10. And what happens when we distribute that 10? 10n plus 10, okay? And this one is nice because we don't have a negative to distribute. We just have a plus in between them. So we can go straight to putting it as one fraction and combining like terms. So this is why I didn't practice addition with you guys, because addition for you guys is more intuitive. You guys are going to be default more comfortable with addition. So if we combine like terms, what should we have in the numerator? 10n plus 14, okay? Now, what should we do with the problem so that we can simplify it? Should I cancel out the 10s?
No,
That would kill not a kitten, a puppy would die for that because 10n is adding to 14 here, but a 10 is multiplying there. So if we tried to cancel this out, we would be taking an addition problem and canceling addition with division, and that's why it wouldn't work. Can't do it then because it's still canceling addition with division. we'd kill another puppy. So the way we have to do it is we have to factor the top. We have to take the top and write the top as a multiplication problem. Because if the top is written as multiplication and the bottom is written as multiplication, then we can cancel multiplication with division. So if we factor the top, what type of factoring is the top? 2. It's a GCF of 2, right? Okay, so let's factor out the 2. And when we factor out the 2, what's left over? 7. So even though it feels like a 10 should cancel, a 10 does not cancel. What actually reduces? Only a 2 reduces. Even though it feels like a 10 would have reduced in the problem, it doesn't. Only a 2 does. So we're going to reduce by 2. And then we get 5n plus 7 over 5n times n plus 1. Again, we cannot reduce the 5s because this is not a 5n, this is a 5n plus 7, and that's just a 5n, and those are different. So we're actually done. So number 7, I tricked you because there's 2 exclamation points. Yeah, so number 7 is an exclamation point. Number 7 is one of the exclamation points. My punchline wasn't as long as it needed to be, so I put exclamation points on it. No, I needed there to be 10 of them. That's fine. That's fine. No, you have to do the problem. You can say that this is what the answer is going to be, but you have to do the problem. Yes, you have to do the work. You got to do the work. I'll come over and help you with 4. All right, I'm going to let you guys get to working. Yes, I'm gonna come over and help you get those graded. Also. All right. Marvelous.